Example 2, a simple one-line diagram is shown in the following figure. That means this one. Okay. Then the ratings of, it is rating, that means the rated value. Okay. The ratings of different equipments are as follows. Number 1 is G1 and G2. That means generator 1 and generator 2. So you have 300 MVA, 20 kV, R 0.2 PU, X 0.4 PU. So the first thing you have to do when you get the question or when you get the diagram, you will write whatever it is saying, you will write under this like this, 300 MVA. This is a good practice. Remember, when you do math, this is a good practice because when you, okay, let me show you something. Pause. So you go to the market and you buy a what? A transformer.
Hello,
like
sir.
this. Hi.
Recording হইতেছিল না স্যার।
Hi, ঠিক আছে। When you go to the market and you buy a a transformer that can do this 230 step down to 12 volt, right? After coming home, you connect that transformer to your power system or power line. Then your power and your voltage was 200 volt. Are you going to get exact same 12 volt at your output, or you will get less than that?
Less than that, sir.
Exactly, less than that, right? So
Yes, sir.
maybe you have bought 230 to 12. That is your rating, right? Rated value. But that doesn't mean that you will be using that value at that time. Understood? So maybe this transformer rating is 40 to 400. That doesn't mean I will is 40 and I will get 400. That doesn't mean that. Okay? That's why this is called rated. And those values are actual. Now, the R is 0.1, X is 0.2. This one and this one both. Now, the R is equal to what? 50 ohm for this line, and X is equal to 75 ohm for this line. These are what value? These are what? These are actual value, right? These are actual value, not per unit. These are actual value. Now, for the load, that means this one, the value is 500 MVA, 20 kV, 0.8 power factor lagging. This one is new, right? This one is new. Why? Because normally the loads are what? Inductive or capacitive, right? So here this load is inductive. How do I know that?
Lagging, sir.
It is lagging, right? Lagging means mostly your load is inductive. Got my point? And how do I know it is not purely resistive? Because it is 0.8. If it was purely resistive, then it could have been 1. Okay? Since it is 0.8, that means less than 1. So there are some inductive element here. Okay? Now then, after writing everything, then choose the base 350. See, this one was 300 MVA. This one was 400 MVA. This one was 400 MVA. This one was 300 MVA, right? And the load was 500 MVA. But you have to choose a base that is nothing like anything else. So you have to choose a base that is 350 MVA, that is different from every one of them. Okay, fine. Now, the generator voltage was 20 kV. This is the rating. But you have to choose a base that is 30 kV, right? That means that is also different on G1 circuit. That means maybe the rating is 20 kV, but you have to use it at what? 30 kV. That means if you give here, you have given 20, this one was 40 to 400, right? This one was 400 to 40. Got my point? And this one is what? This one is again 20. And this one was what? 20, right? Now see, but they said to use 30 kV on generator 1, okay? So the new, that means the base is 30. This is the new base. This is the old base. This is a new base. New base is 30. So if this is 30, this is also 30. So for 40 become 400. So what about 30?
300.
30 will become 300. So this is also 300. This is also 300. Now this will be what? 30. So how much
30.
your generator will be? Generator again, since they are at the same point, this voltage and this voltage should be same, right?
Like 30.
Generator voltage should be 30 now.
30.
And what about the load?
30.
30. Now everything is matched, right? Previously nothing was matched. Nothing was same, right? Nothing was matching it to each other. Now everything is matching. 30, 30, this is 300, this is 300, this is 30, this is 30, this is 30. Understood my point? What is the importance of base matching everything? Understood?
Yes, sir.
Okay. Now then you have to find out the new R, new X, new R, new X, and new R, new X. So everything is like that. Here, one important thing is in the load, you do not have any what? R and X, right? But you have what? You have power factor. From power factor, we will find out R and X. Now, draw the impedance diagram with series load and parallel load. Series load and parallel load, draw the impedance diagram. What is series load and parallel load? We have done it before. What is series load and parallel load? Here, right? Here. R is equal to V square PU divided by S PU into cos theta if it is in series. And X will be what? V square PU S PU sin theta. Got my point? Everyone?
Yes, sir. We get.
What is cos theta?
Cos theta, sir, power factor.
Power factor. What is sin theta? From there, we will find out the theta. Then we will put the theta to the sine, right?
Yes, sir.
Okay. So we already
sir.
know what is our series loading, what is our parallel loading. We already know, right? So you have to find out, or you have to draw two diagrams, one for series load, another for parallel load. Okay, let's find out the series load first. What is the drawing? What is the drawing? What is the drawing? Here, this one. This one is for the series load. How do I know that? See, at first you have a generator. So you have a voltage, you have a resistance, and you have a reactance. Then you have what? A transformer, right? One resistance, one reactance. Then you have line, one resistance, one reactance. Then you have transformer, one resistance, one reactance. Done. Then you have another generator, right? So one voltage, one resistance, and one what? Impedance. Then you have a load, right? And this load is series load. Series load means your resistance and your reactance and your resistance will be what? In series. Got my point?
In series.
Okay, now good. Now, if you go for the parallel load, what will happen? Everything will be same, just this part will be what?
Connected in parallel.
Connected in parallel. Okay, got my point? Everyone? Now,
Yes.
you know how to draw the impedance diagram, then you know how to find out the reactance diagram, right? How do I find out the reactance diagram?
Sir, we make in the
This one will be gone, this one will be gone, this resistance is gone, and the whole load is gone, whole load.
Yes, sir.
From here, so what are the things are left with? This, right? So in reactance diagram, series load or parallel load doesn't matter because the load will be gone, right? So this job is done. That means I have drawn the impedance diagram and I have drawn the reactance diagram that you already know. What are the things you do not know? Now you have to find out the values, all the values. You have to put all the values. Got my point? Hello? You have to find out the values.
Yes, sir. We
Okay.
get, sir.
Okay, now let's find out the values. First, solution. What is your new base? 30 kV and 350 MVA. Where? Where means from where you will start?
T1, sir. Generator 1.
Okay, if they said it is not generator 1, if they say it is transmission line, then remember I have drawn with the green color here 30, right? Then here 30, right? Then here 300, right? I have drawn, right?
Yes, sir.
So if I tell you choose base on transmission line, then you have to draw the number at transmission line first, then you have to go to the transformer, then you have to go to the secondary part, then you have to go to the generator, then you have to go to this side, right?
Yes, sir.
Then it is 30, this is 30. So this is the point where you will start writing. So in this case, they have said G1 circuit, that means this one, G1. So this is our G1. Now your base for G1 is what? 30 kV, and your equipment is generator. Your base to V base is 400 into 30 divided by 40 is equal to 300 kV. This is already calculated because I told you, remember, if this is 30, this one will be what? 300, right? Then you have line equipment for the region 3. Region 3 means this part in this side. So you do not have to remember in your exam, you do not have to give me region 1, region 2, region 3, something like that. No, not like that. Do not do this. What you do? You do like this. You do like this. At first, generator 1, right? You draw like this. What is your old base? V base, right? V base old. What is your V base old?
40,
Sir.
sir.
No, 20.
20, sir,
Generator
yes, sir.
20 chilo. Now V base new. What is your new base?
30.
30 kV. What is your age base old?
300, sir.
300 MVA, right?
Yes, sir.
What is your age base new?
350.
The new 300 or 400, sir.
Oh, yes. Was it 400? Was it 400?
Sir,
Yes,
old,
it
sir.
was. Yes. No, it was 300. New হচ্ছে 350.
Oh, yes, sir.
New is 350. Okay? And your R PU old কত ছিল? RPU হলো 0.2. Okay? And your XPU, how much? Old is 0.4.
Yes, sir. 0.4.
This is the value that is given. Now you have to find out what? You have to find out what? Can anyone guess what you have to find out?
Sir, we find out RPU or
See.
Sir.
You have to find out this one. You have to find out the voltage, that means power unit voltage. You have to find out the power unit resistance, and you have to find out the power unit reactance, right?
Reactance.
That means your V, your R, and your X. All of them in per unit. Okay? Got my point?
sir.
Okay.
Yes, sir.
Now here, I'm going to write this one. Your voltage per unit, right? How much? Actual divided by base. What is your actual?
BU.
20 kV, right?
Yes, sir.
What is your base?
30.
30
30.
kV. So how much you got?
0.1.
0.66.
0.66.
667, right? Something like that. That means 0.6666, something like that, or 0.67. Got it, Abdullah Bucha?
Yes, sir. Which?
This is your rating. That means your actual. This is your base. So actual divided by base, or rating divided by base. This is your per unit voltage. So V is done. What about your R? RPU new. RPU old into V base what? New or old?
Sir. Old, sir.
Old, right?
Yes, sir.
V base nu whole square, right?
Yes, sir.
Into S base nu,
No.
S base old.
All.
Are you familiar with this formula?
Yes, sir. We are
Yes, sir.
familiar, sir.
Okay, all of you remember this one?
Yes, sir.
Okay, now let's do it. RPU old is how much?
22, sir.
0.2. Then V base old is how much?
20.
20. V base new is how much?
30 kilovolt.
kV. Since both of them are kV, so you do not have to worry about the units, right?
Yes, sir. Yes.
Then S base, how much? New.
350, sir.
350.
350.
Good. 300, right? If I use a calculator, then how much you got? 0.2 into 20 divided by 30 whole square into 350 divided by 300, right? So you got 0.1037. Okay? Got my point, everyone?
Yes, sir.
Per unit. Okay, let's check whether the result is correct or not. Yes, result is, okay, the result is correct or not? Result is correct. 0.706. Why?
Because of, sir, the fee based news, S based news, sir, and S based always will be vice versa.
Okay. Okay. Oh, new is how much? New is 300, 350, right? Old is 300. Right?
Yes, sir. It should be vice versa here. S
Okay.
based new.
What they have done? Okay, wait a second. What they have done in the question? 320, 350 and 30, right? It's correct. So for generator 1, RG new, RG old, V base old divided by V base new. V base old was 20, V base new is 30, that's correct.
আমাদের
S
উল্টা
base
হয়েছে,
new, হ্যাঁ?
আমাদের
আমাদেরটা
হয়েছে,
উল্টা হয় নাই,
উল্টা।
আমাদেরটা উল্টা হয় নাই। Look at this. S base new is 350. S base
Yes.
old is 300. So there they made a mistake, right?
Yes, sir.
Not us. They made a mistake for some reason. I do not know why, but for some reason they made a mistake because our new base is how much?
350, sir.
350.
350, yes, sir.
Got my point?
Yes, sir. Sir.
Yeah.
Also, there's another mistake, sir, for the
নিচে স্যার, নিচেরটা
first page, sir.
For first,
Yes, sir.
which one?
Example 2.
Where?
From G1 and G1, sir. Also, there's a 2 G1 here. Yes, sir.
G1 and then G2. This will be G2. Okay. So this was made by my sir. Maybe he was in hurry. That's why he do some typing mistake. Maybe. Okay.
Maybe yes, yes.
Okay, but you know how we got this, right?
Yes, sir. We know.
Okay. So that was the formula. So let's go to the whiteboard and do this. Okay. Now this one is 0.1037 per unit. Now for X per unit new, the formula is what? X per unit old into V base old, V base new whole square into what? S base new, S base old, right?
Yes, sir.
So your X is equal to how much? 0.4. This one was 20 by 30 whole square, 350 and 300, right? So how much you got? 0.4. You got 0.2074. How much?
22074, sir.
Per unit. Understood, everyone?
Yes,
So
sir.
this is for G1. Now, what will happen for T1? Let's go for that one. Now our next stop will be what? Transformer 1, right? Our next stop will be what? Transformer 1. Now, what was the transformer ratings? 440 by 400, R is equal to 0.1, X is equal to 0.2. Understood, everyone? So your V base old for low tension side, that means low voltage side, how much it was?
40.
40 kV. Your V base old for high tension side, because transformer has 2 voltage, right? Was how much?
400.
400 kV. Now your V base new for which side?
Low tension sir.
Low tension side, because we already know the generator voltage is how much?
30 kilovolt sir.
30 kilovolt. So how much will be your V base, not old, new high tension side, how much?
Will be sir.
You will divide that 400 by 40 into what? 30.
kilovolt.
So your V base new high tension side will be how much? 300 kV, right?
Yes sir.
What is your S base? S base old. How much is your S base old? 400 MVA. From the question, I am actually seeing the question, okay? So I know 400 MVA. What is
Yes,
your
sir.
S base new? S base new. What is your S base new? Anyone?
Sir, maybe 350.
350.
Yeah, 350, right?
Yes sir.
It is 350. So let's write 350. What is your R PU old? What is your old value? 0.1. How much? 0.1. Understood?
Yes sir. PU.
What is your XPU? 0.2 maybe. Yes, 0.2. Okay, everyone, got it?
Yes, sir.
Yes sir.
Now you have to find out what? You have to find out what? You have to find out X and R, right?
Yes, sir.
Why? How do I know that? See, if you go to the impedance diagram, what are the things that you have to know for transformer 1? Do you need to know the voltage? No.
No, sir.
You need to know the what? You need to know the resistance, and you need to know the reactance. That means X and R. Right?
Yes, sir.
Okay. So let's find out the R PU new, right? What is the formula? Same formula as before. Which one? R PU old into V base what? Old V base new. Which one you will choose? High voltage or low voltage? Abdullah, which one you will choose? High voltage or low voltage?
No voltage.
Eta holi holo, right? Anyone.
Yes, sir.
If you choose high voltage, if you choose low voltage, choose the low voltage. If you choose high voltage, choose the high voltage. Understood?
Yes, sir.
Eta holi holo, doesn't matter. For this one, this is S base new. This one is S base old.
Old.
So what is the value? 0.1. This is old is 40. This is 30 whole square. This is new, right? 350. This is what? 400, right? So how much you got? 0.1 Upper one is 14, lower one is 30. This one is 350, this one is 400. So if you got 0.156. So how much we got? We got 0.155, right? Now for your XPU, again, same formula will be there. Now if you use the same formula, then you will got something like this, 0.311. This is PU, this is PU. Okay, let me check. Your generator one, S-base was 300. For transformer one, S-base new, 40, S-base new. They made a mistake here as well, okay? So do not follow my note, okay? Do not follow my note. Here you can see they do not follow my note because S-base new should be what? 350, right? And S-base old is how much? The generator, what? MVA was 400. So it should be different. Got my point?
Yes,
Yes,
sir.
sir.
So use my one. What I have shown you this, use this one. So this is your X. So you know your transformer one. Now next what? Next you have to go for the transmission line, right? TX line. TX line. What is the V? V base. What is V base for transformer? From transmission line? Because there is no old, there is no new here. Got my point?
Yes,
Because
sir.
why? Do you know why? Why there is no old, there is no new needed? Because the value was given. The value was given in what? The value was given in actual, right? If the values are given in actual, you do not have to find out the old base, new base, nothing. No. Got my point? Because the values are already given in actual, 50 and 75. Understood?
Yes, sir.
Yes, sir.
So let's find out the V base. What is the V base for transmission line? Anyone? For generator, the V base is 30 kV. But for transmission line, it will be how much?
300, sir.
300.
300, exactly. And what is your S base?
350, sir.
350.
Right, everyone? So can anyone say me what is the formula? What is the formula for R for transmission line?
R, sir.
Yeah.
The voltage divided by impedance.
What is the base? What is the base formula? There's Z base or R base or X base. Anyone? Anyone?
Sir, again?
What is the formula for Z base?
Sir, Z base is equal to V base divided by impedance, sir. V have a
V base square divided by
impedance.
S base, right?
Yes.
So what is your V base? V base is 300. kV, remember it is in kV. kV means you have 30, right? Whole square divided by S base. S base means 350 MVA. MVA means 6 zeros. Right? Got my point? So what is your Z base?
Yes, sir.
What is your Z base now? Square divided by 350.
180.
It is 257. It is how much? How much it is? 257. Now what is your R? What is your R actual? That is given. What is your X actual? That is given. So what is your RPU? Actual by base, right? Actual by base. What is your actual? What is your base? See, Z base is equal to R base is equal to X base, right? Both of them are same. All of them are same. All of them are ohm and ohm. So they become 50 divided by 257.14. So your value is 0.1944. PU. What is your XPU? Again, X actual divided by X base, right? What is X base? The same thing is X base. So it is 75 divided by 257.14, right? So upper one is 75. 75 divided by 257.14. Your value is 0.2916, 0.293 actually. You got it? XPU and XPU, RPU for the transmission line, right? Hello? Hello?
Yes, sir, we get, sir.
Okay. Now for
Yes,
the
sir,
transformer 2. For transformer 2, what will happen? Everything is same. Just your old your high tension will be low tension, and your low tension will be high tension. Got my point? Not actually. That actually your high tension, low tension will not be different. That means the side will be different, but the calculation will be what? Calculation will be what? Will be exactly same. Understood?
Yes, sir.
Calculation will be exactly same. Now for the generator 2, how much will be your generator 2? Again the same value. Okay? The generator 2 is what? Again the same value. What about your load? The load will be different. Load will be what? Hello? Your load will be different. Got
Yes,
my
sir.
point?
Yes, sir.
Yes, sir.
How your load will be different? What is the formula for your load? Anyone? Anyone? Load will be different. Anyone? What was the formula for load? Okay, let me see that. And let me show you that actually. Let's go back. Here. For series load, let's find out the series load first. What is this? RPU, right? You have to use what? VPU square. Then you have to find out what?
SPU, sir.
SPU. Then you have to find out what? Cos theta, because cos theta is already given. So let's find out this first. So your load calculation will be like this. Your V per unit. How much is your V per unit? V actual by V base. So actual is how much? What is the actual value?
20, sir.
20? Was it 20? Okay, let's
30, sir.
Okay, no. Was it 20? Okay, let me see the picture first. Let me see the question first. Oh yes, it was 20. Yes, it was 20. Right?
Yes, sir.
It was 20. So 20 divided by base. Base is how much? 30. So how much is this?
0.66.
Okay. Now the SPU, because the formula is like this. The RPU formula is this, right? VPU square SPU First step. This is the formula. So what is your SPU? Again, S actual, S base. What was your S X actual? Go to the question and see. It was 500 MVA. How much?
500 MVA, sir.
MVA. What is your base?
350, sir.
350 MVA, right? So this value will be how much? 500 divided by 350. This one is 1.4287. 1.4286. Okay, this is PU. And what is your cos theta?
0.8, sir.
0.8. Remember, it is lagging, right?
Yes, sir.
It is lagging. Okay. Now the value will be 0.667 square divided by 1.4286 into 0.8, right?
Yes, sir.
So the value will be how much? So the value will be okay, fine. Well, let me find out. Maybe 0.25, maybe 0.25, something like that. Okay, 0.667 square divided by 1.4286 into 0.8.
0.25.
Yes, 0.25. The value is okay. Now what about your XPU? Again, same formula. This one will be what?
Sin theta.
Sin theta.
Sin
So,
theta minus
okay, from here, can you find out the theta?
Yes, sir.
How to find out the theta?
Point.
Cos inverse 0.8, right? Then now what is your sin theta? Sin theta will be sine. Whatever the angle you are getting from here, you put the angle here. Got my point? So let me show you something. Let me show you this calculator. Yeah, calculator. So how do I find out? See, sine, shift, cos inverse, 0.8, bracket close. You got the cos value, sine value, 0.6, okay? Directly. Can you see that? You can find out directly. So you do not have to do it elaborately. You can find out 0.8, 0.6 actually. So if you put that here, 0.6, and everything else, what about your result? This one will be 0.19 or 187. Okay? And your result is correct, 187. Okay, got my point? This was for series load. This was what? This was for what?
Series load.
Series load. What about the parallel load? Parallel load will be, in place of multiplication, it will be what?
Cos sir minus bag hoye jabe.
It will be divide, right?
Yes, sir.
It will be divide. So if I divide that, so the RPU would be what? 0.39 per U. What about your XPU? It will be 0.52. বুঝতে পারছে?
Yes, sir.
So you understood, right? Cos theta will be at the bottom. That means it will be divide. So sin theta will be at the bottom. Bottom means with SPU. So it will be divide. So this is your result. And your result is correct. 0.39 per unit, 0.52 per unit. Okay? So your load is done. Now, what else are remaining? Nothing else is remaining. So you have to draw the 1-line diagram and what? You have to draw the 1-line diagram and put the values. Got my point? For series one, for parallel one, and for reactance diagram. Got it, everyone?
Yes, sir.
Can you do it for example 2.1 and example 2.2?
Okay, sir.
Okay, do it at your home. Okay.
Yes, sir.
Now example 6.10. আমাদের midterm syllabus. Okay, let me do it first.